This is our live lab on how you can automate your Azure data pipelines. My name is Paul Lacey. I am the head of product marketing here at Ascend.io. I'm joined by Alesh Mistry, who is our field data engineer here at Ascend.io. Alesh, welcome. Good afternoon to you, sir.
Thank you.
Yeah, we're really pleased to have you with us. Alesh is the smart person on the call, just so that everybody can understand how this works. But we're here today to help you figure out how you can automate your data pipelines on Azure. And so here's our agenda for today. This is intended to be a live lab. So we're going to be diving into code. We're going to be looking at different applications of automation. So I'm going to shut up here very quickly, and we're going to get into the real meat and potatoes of the talk. But just to start out, I want to anchor us in what is automation, because automation can be a fairly nebulous term for a lot of people. Obviously, people know what it means to automate stuff. We've been automating things for centuries now. But in particular, when it comes to data pipelines, what does it mean to automate those? So we're going to start there, and then we're going to go into investigating an Azure pipeline that we might want to automate. So we'll look at what the current state of that pipeline is today. Then we're going to talk about how you can port or move that over into an automation platform or an environment where it is possible to automate your pipeline on Azure. And then we're going to wrap up by reviewing the benefits of doing that. But the bulk of our time here today is going to be on parts 1 and 2, which is what does it look like today, and what does it look like? How do we begin to automate that? But first, let's talk about what it means to automate your data pipelines, because a lot of people, they hear the words automation. They say, yeah, I understand that means something that's like, I don't have to do anything and things happen. But in particular, what do we mean when we talk about automating data pipelines? So the first one is, as a data engineer, we find that we have to spend a lot of time on change propagation throughout a increasingly complex network of data pipelines. So this might look something like what your data pipeline landscape looks like today. You've got a bunch of different data pipelines that are running. They're all feeding each other. The keen eye amongst us might recognize this as a bit of a DAG, where we have a bunch of different steps of data pipelines that are all feeding into each other, different discrete data pipelines that stop where others begin and pick up that data set and do other things with it. And this is typically what we see, especially over time, as people start to build more and more complex products out of their data. You've got a lot of different pipelines that are all built on top of each other. Now, the question becomes then, if you need to go in and change something in a single pipeline, what happens? How do you do that? Let's say we wanted to go change this pipeline right here, and we needed to change a definition of a business rule, or we needed to change some SQL or some Python logic. That's going to fundamentally change the data set that is produced by that data pipeline. Now, raise your hand, and I do realize this is a webinar, so no one's going to see you actually raising your hand, but raise your hand if you've ever spent time on impact analysis for a change you want to make to a data pipeline. Yeah, I see a raised hand. Thank you. Yeah, we got some people saying we've done some impact analysis, right? And I'll bet you a bunch of people would say that the impact analysis might take longer than the change itself. Because the change itself is typically, I know what I want to do. I just want to edit the SQL. I want to change the logic or this, that, and the other. But then what happens after I do that? Who's impacted downstream? Is my data that's coming through upstream going to be compatible with this change, or is there going to be an error or a breakage at some point in the future? That's one of the big gotchas when it comes to working in complex data pipeline networks. And one of the things that we can automate about this, if we have the right tooling in place, is the propagation of that change throughout the entire property of data pipelines. So not just that particular single data pipeline, but all of the data pipelines that follow as well. So in an example where we are able to automate this, let's say we just go in and we make this change, and we can see that little red dot representing the part of the pipeline that we're changing. And then the controller automatically knows that all these other steps are downstream of this. It looks at the pipelines holistically, not as individual atomic elements, but says, I know that not only this pipeline, but all these other pipelines are also dependent on this change that's happening. And so that means that I need to propagate this change all the way through the network until I know that it's a good change, until I know that it's completely made its way through the system. And the added bonus is if we're able to fully automate that without a lot of manual orchestration, without having to go in and rerun jobs and figure out the sequence of rerunning jobs and things like that. It can get really complex if you've got to go in, and sometimes you just have to just wait and say, I'm just going to wait till the nightly run kicks off again, because the nightly run does everything in the right order. But that means that there's potentially hours, if not days, of when the data set is not up to date with this new definition that I've created. And people in the business are doing things with the data, and the data set is now out of date, which is not an ideal situation. So if we're able to automate those things, it makes life so much easier. So here's a data pipeline, and we're going to get into this in a lot more detail. But what I'm showing is we're going in, we're making a logic change. So it's just pretty simple, changing a scalar value that's inside of a calculation in a data pipeline. Now, in most cases, this would mean we have to go into some sort of a scheduler or an orchestrator and rerun the pipeline and figure out what to do. But if we're able to fully automate the orchestration of this pipeline as well, we can see that the pipeline starts running automatically right away as soon as we make a change. And then it starts flowing the change through the rest of the pipeline, just like we were talking about before. And we also see it started immediately at the point of change and it propagated that forward. So we didn't have to go back and rerun a whole bunch of the pipeline that was prior to that change, where no impact was made by this change. We were able to just simply go right to where we wanted to, surgically update something, and then have that thing just propagate through the rest of the system. And in doing so and developing in this way, we're able to understand and know that the data sets are always up to date throughout the entire day that we're working on our data pipeline. So there's no concept of let's run it every night, let's run it every week. But we know that up until that point, the data might not be current if somebody's going in and doing something different with it, which causes a lot of friction and a lot of pain for a lot of people that are working with data within the organization. If we're able to automate the orchestration of data pipelines, eliminate manual orchestration, we can do things like turning that over to the system and allowing the system to just automatically pull forward, find the jobs that need to be run at any given moment in order to keep the data set up to date, and then just propagate those all the way through the system, which is really fascinating as well. And we see a lot of people, once they switch over to this paradigm, they go, oh my gosh, there's no going back. It's so much nicer to just know that things are always up to date. And if there's not, there's an error that's very easy to find and I can go pinpoint it. There's no 2 a.m. pager alerts anymore that a pipeline did not run successfully, and therefore I got to come into work early the next morning and make sure that the data is accurate before the CEO looks at the chart and flips out. So all this stuff is just a complete paradigm shift when it comes to automating your data pipelines. So how do we do that? What are some of the requirements that we need in order to automate these pipelines? And then we'll get into specifically on Azure, what does that look like in just a moment. But we've been doing a lot of work here at Ascend. We've been around for almost 8 years now. And during that time, we've been building out tons and tons of iterations of these pipeline automation platforms and come to what we consider to be the latest and greatest version of it. And here's what we've learned along the way. So there's 3 things that you need in order to be able to automate your data pipelines. The first one is you need integrated tooling for all steps of your data pipeline. And what we mean by that is you have to have ingestion. So being able to go out and grab data from wherever it is, from S3, from MySQL, from Postgres, from SaaS applications where it might be living today. So basically you have to be able to go out and grab that data and pull it in to some sort of an analytics environment, whether that's Snowflake or BigQuery or Azure Synapse. You got to be able to pull that in. And then you've got to be able to transform that data. So you need to be able to define your transformation steps in logic in SQL or Python. Then you need to be able to also reverse ETL that data. So sometimes you need to put that data back out into a Postgres database or a MySQL database or Microsoft SQL or whatever you're using on the operational backend, so that data can be used by applications in real time. And then obviously you need to orchestrate, schedule, all that kind of stuff. And all those things need to exist. They need to be integrated together in order to automate a data pipeline, because a data pipeline is a collection of all 4 of those things together. And if you don't have those parts of your pipeline talking to each other, there's no way that you're going to be able to do an automation like what we just demonstrated a moment ago. You'd be stuck jumping between manual hoops and triggering things manually and that sort of stuff. The first step is you need an integrated set of tooling. Ascend is a platform that does all these things all together. It is possible to manually integrate these things together too, but that's just one of the prerequisites. Is you've got to somehow manually integrate together all these different steps. Now, the second thing is you need rich metadata about the data sets that you're working with. You need to, in the case of a more sophisticated incremental data pipeline, you need to be able to track the partitions of your data as they move through, because as people get more and more sophisticated, oftentimes they'll say, my data sets are so large, I can't just hit the table every time I want to reprocess something. I need to go surgically in and say, okay, I'm just going to reprocess the last 30 days of worth of data or something else, because it's getting too expensive otherwise in the cloud. And so you need some sort of a partitioning system that helps you do that and collects all the metadata about the partitions and helps you find where they are in the different tables and that sort of stuff, so you can flow things through in an automated fashion. And then the second thing is you need to be able to understand, this is the data ops component of it. You need to be able to understand the code version that ran against these data sets. Because as we all know, as you start to work with data pipelines after day 1 and you start editing them and changing them, you're going to wind up with a situation where you've got some data that has been processed by the old version of the code and some data that's been processed by the new version of the code, especially if you've got an incremental data pipeline. And you need to be able to reconcile, make sense of, okay, which version of the code operated on this chunk of the data set, so that I can understand, is this data set out of date or is it up to date with this new logic? Does it need to be reprocessed or not? You need to be able to have that visibility into your data sets. Lots of pioneers have done some really cool stuff to build some of these things manually. What we have done at Ascend is we basically productize that into a platform that gives you all this stuff out of the box. But this is definitely a requirement. You need a ton of metadata in order to be able to run these kind of automation workflows. And then the final thing is you need an intelligent automation controller. So with those 2 things combined, with a single platform or a single integration of all these different steps, with the metadata that is required to be able to figure out and reconcile, okay, what's up to date, what's not up to date, what needs to be reprocessed, you then need an intelligent automation controller that can feed off of that metadata and say, okay, I know what needs to be done next in this network of pipelines in order to bring everything up to date and make sure that everything is current with the version of the logic. Or if there's a hold on the system, if you want to say, I want to pause everything, I just want to do a bunch of work, and then I just want to let it go and let it completely reprocess, the controller understands that logic as well and says, I'm not going to do anything for a while until I'm unpaused and unblocked to go just rerun and reprocess all these different parts of the data sets that are now out of date based on what I can see in a global version of the data pipeline properties. So that's automation in a nutshell. If there's any questions, please feel free to put those in the chat. We'd be more than happy to circle back to this and talk in a little bit more detail about the theory of how do you automate a data pipeline, because that's quite fascinating and something that we've been thinking quite a bit about here at Ascend. So what we're going to show you here today is an automation platform built on a single pane of glass. So the Ascend.io automation platform is a single centralized platform that helps you ingest, transform, orchestrate, and share your data across a variety of different data clouds and a variety of different hyperscalers as well. We're very platform agnostic, so the platform itself can be deployed in a variety of different contexts. It can be deployed in a containerized way if you're trying to run it in a specific region. It can be deployed on a cloud version if you just want to have some SaaS credentials and log in. And it does everything required to provide some of the automation that we're going to be going over here today. And so without any further ado, let's go ahead and get into exploring the current state of an Azure pipeline that you might be working with. And then what are the steps you might want to take in order to automate that data pipeline like we just talked about. And for that, I will hand it over to the much smarter Mr. Alesh Mistry. So Alesh, please take it away.
I'm not sure about much smarter, but I'll certainly take it away. So let's share my screen and hopefully you can see it. If Paul, you could confirm, you can see my screen?
I can confirm. We've got the whole screen. Yes.
Perfect. So essentially what we've got here and what I'm going to attempt to do is I'm going to attempt to build a pipeline using Azure Data Factory and then subsequently build a similar pipeline in Ascend. So therefore you've got you'll go through some of the kind of the differences and also some of the pitfalls and how you can improve that with the Ascend experience. So first of all, what I'm going to do is build a pipeline. So straightforward, I'm sure you've all seen ADF before, but essentially what I'm going to do is build a new pipeline. And first of all, I'm going to copy data. The use case for this is that I'm going to take data from S3 and move it over to Snowflake. And I'll talk about some of the experiences I found when I was building this pipeline, having used other tools as well, and some of the pitfalls. So I've copied data. It's copied the component across into my workflow. Now I move over to here. I'm just going to rename that pipeline. I'm going to call it Ascend Webinar Pipeline. Okay. Now what I'm going to do is add a source. So a source data set here, I'm going to select, there's none there. So I'm going to create a new one. I'm going to hit S3 and continue. Delimited text. And now what it's going to ask me to do is going to link to a service. So I'm going to click over to my Ascend demo service. And then what I've got to do is when I've got my link service, then I've got to browse for the right area. And what I've got is lots of folders in the bucket. I'm going to pick this one in particular, click down to our weather data, click to sensor, and I'm going to pick one file. So all I've done there is essentially connect to my source. Okay, now the next thing I want to do is sync. So I want to sync that data set. What you can also do is rename it. I'll rename it slightly later. So the next thing is I've configured my source. I think that's all good. So configure my sync. Again, no sync data set. That's the one that we just created for the source. So go to new, and I'm going to go to Snowflake. Now, one thing that's worth noting is that there's a lot of process here, and there's a lot of clicks. So essentially what I've got is another link service. So I'm going to go to my Snowflake trial, and then you've just got to wait for it to load its table names as well. One of the things I experienced is that when I was I couldn't link to a Snowflake instance, which wasn't on Azure. I'm not sure if you guys experienced something different, but when I was setting up the trial, our Ascend Snowflake trial instance was on AWS. And I realized that I couldn't use that for a source or sync as well. So I had to create a trial account, Snowflake trial on Azure to actually get it to work. So I'm going to select my table now, and I'm going to go to the raw database here. So now do OK. I think that's good. So now I've configured my sync. Okay, just wait for it to acknowledge that. One thing I've noticed on ADF as well, there's a lot of waiting around, and we'll experience that in a few minutes again when it catches up. Okay, so now I've got my source, I've got my sync, I've got my mapping. So you can import the schema at this point, which is neat. So it's going to ping the source, and then subsequently ping the target and make sure that the schemas match, such that you can make sure that the source and target table match. Another difference between ADF and Ascend is that in ADF, you've got to have the target table there in order to sync to it, and you've got to have it matching the schema as well. In Ascend, it will automatically generate that for you. So my mapping's there, but there's one final thing I've got to do. I've got to enable staging here. Now, this is something I was interested about, because essentially what the staging is, that it's a landing area in Azure. So I'm hooking up to an S3 bucket on AWS, but I still got to have a landing area on Azure to actually take my data from, and then it's going to pull that from the Azure bucket, Azure blob, and then move it over to Snowflake on Azure. So that linked service was something I wasn't expecting as well. So I've got my storage.
So sorry to interrupt, but is that a blob store on Azure? How does that work?
Yeah, so basically what I had to do was that I had to, if you think of the flow, I had to create a container, and this container is called, I just called it Ascend, but this was a container I had to create on Azure such that I could stage the data on Azure first and then move it over to Snowflake on Azure. So it was like a hop. It was an unexpected hop, but it's a hop essentially.
Got it. So so you have to materialize the data in the Azure data plane before you can start working with it inside of Azure. So that's an extra. That's a really important. The reason why I asked the question, like, sorry to interrupt, is it seems like a really important gotcha for folks to be aware of if they're trying to do something like this. And if you're trying to do this with us in real time, it's just something to be aware of as you're clicking through your own environment, that this is a requirement.
Yeah, exactly. So essentially what I've done there is that I've configured that first step of taking data from S3 and landing it in Snowflake. Okay, so first of all, I'm going to validate that pipeline. And if I've done that, there should be no errors. So that was a good point. And now what I'm going to do is I'm going to trigger that pipeline. So I have to manually trigger, and I'm going to do that. I'm going to do that because I want to. Okay, so yeah, another great point. I forgot to publish. So now what I've got to do is publish my pipeline. But it's a great gotcha because I'm used to working with Ascend, all of this stuff is automatically done for you. So it's just publishing the pipelines now, and we get a nice publish complete. And now what I'm going to do is I'm going to trigger now. And this should hopefully trigger the pipeline to run. Now, the way that we monitor this in ADF is that if I go over to monitor here and refresh that, you can actually see that's now running and that's in progress. Now, I'm one of those developers that I don't fully trust anything. And therefore, what I want to do is I want to see that data land, right? So what I've got is I've got my Snowflake instance here, and I'm landing into raw, and I'm just going to test that. So there's no data in there yet, but that's because it's not quite finished yet. So I'm just going to refresh that and wait for that to land. Now, this is another big differentiator, because like that monitoring process and understanding how far your pipeline's got, and also understanding the errors, is an important part of development for me. So when I'm building pipelines and taking data from X to Y to Z, then I want to know where it's got to and whether there was any errors in that process as well. And that kind of overarching debugging strategy is quite, I'd say it's got its challenges in ADF. So let's just wait for that to happen. It's still whirring away. It's got to 1:17 for that to happen. But just to clarify, what we're doing so far is actually just taking that data from S3 and landing it in Snowflake. So I'm just going to do a quick refresh again. I apologize for it taking a while, but it wasn't actually that much data. It was just a small amount of data. So we'll just have to bear with it until it finishes. Let's just give it one more refresh. And hopefully what we'll do is that hopefully some of it has landed. So we go back to ADF test webinar raw. And yeah, I think some data's now landed. So that's pretty cool. So you can actually see that data's in there now. That's pretty cool. Excellent. So if we do a refresh, that might have even finished. Yeah, there we go. It's finished now. So what we're going to do is head over to here. And now what we're going to do is do a transform. So what I want to do is I've got so imagine you've got classic warehouse design. You've pulled your data from a raw source. You've now landed it in your warehouse. And from there, you want to do some post-load transformations where you want to take your raw layer to a staging layer. And maybe you want to add some more layers after that, like a business logic layer or a reporting layer. So classic warehouse design, I'm going to do a post-load transformation. So what I'm going to do now is actually go to data flow here. And I'm going to create a new data flow. And in this data flow, I'm going to add a source. And this source is now going to be a data set. So let's look at my Snowflake table. Okay, so I'm going to pick up my Snowflake table that I used. And now I'm going to pick my source option. So I can test that connection, but it's a good connection, so I'm all good. I've got it there as well. Now I go to source options and I'm going to do a query. So I'm not going to pick up the vanilla data. I'm going to pick up a subset of that data. That data was actually weather data that we'll use again in the Ascend version. But essentially, you've got the little query there that I'm going to run. Now, at this stage, I'd actually like to test it. I'd like to test my query because it feels a little bit raw just to put it in there, but you can't do that in ADF. The projection, you've got optimize, you've got inspect, and you've got data preview. There was an ability to preview that data, but you had to turn on a different mode and wait for the cluster. So I'm not going to do that here. So now what I've got is my source configured correctly. Now what I'm going to do is configure my sink. So I'm going to pick the add button there, going to pick my sink, and now I'm going to go to here and select the data set. So at the moment, it's a new data set. I don't want to land it in the same table. So I want to land it in a new data set. So let's go to there. Let's go to Snowflake. Let's go to here, continue, link service, Snowflake trial. And you can tell that I've done this a few times now. But essentially, there is quite a journey to build these sources and sinks and parts of data flows and then link them all together. So let's just wait for the table names to appear. It should be there. That's it. So now I'm going to go to sync. Do OK. Okay, just wait for it to catch up again. And then what we'll do is we'll complete the configuration and then add the data flow to the pipeline, such that what we can do is that we can do the ingest and we can do the transform in one flow. So now we've got Snowflake table 2. So that's the second part of it. Let's just click through the steps. Errors, you can hit settings, errors. I think that's it actually. Okay, so that you can do the preview. So I think that's right. So now let's publish that step. And fingers crossed it should publish successfully. Okay, cool. So now what we're going to do is go back to the pipeline and we're going to add the data flow. Okay, and then what we're going to do is link the first step to the second step. So you can see here now you do the ingest and you do the transform. Okay, so it's just going to do that little SQL statement as a transform, but you get the idea. I'm actually just going to remove this. I'm actually just going to truncate the raw table such that I can remove that first bit of ingested data, and then you can see the process. So essentially what I've got is I've got an S3 ingestion to Snowflake and then a post-load transformation using Snowflake as well. So now I'm going to do publish all, publish that pipeline, publish that change that I just made, and then I'm going to trigger the pipeline. And remember the triggering process, you can do it a number of ways, but I'm just going to trigger it now, or you could add another triggering process, but it's essentially done it in a manual way there. So I'm just going to trigger now and then do OK. So hopefully that should run. That's going to take a while, actually. That's going to take maybe a good few minutes, but essentially we can monitor it from here. And you can see that pipeline 1 is now in progress. And hopefully what should happen is that we should have data in the raw and the sink as well. But the data in the sink will be that the data with the where clause. So the precipitation level is over 1. And you can see that. Okay, so I'm not going to make you wait 5 minutes. What I'm also going to do while we're actually waiting for that to complete is actually go over to Ascend and start building this out in Ascend using the send methodology. And you can hopefully see the differences and the speed at which you can actually use a platform like Ascend. Okay, so we'll come back to that in a second. Okay, and what we're seeing now is the Ascend platform. So if we're not seeing it, Paul, please let me know. But what I'm going to do is I'm going to start from scratch and I'm going to build my pipeline. So what I'm going to do first of all is I'm going to build a new data flow. Let's call that demo df webinar. Cool. Okay, so now I've got my blank dashboard. First of all, in Ascend, we build a read connector. And I'm actually doing a like-for-like comparison because I didn't actually build the connectors themselves. If you notice in ADF, they were actually already built for me. If we wanted to build in ADF, it was quite a journey, but it's a little bit more straightforward in Ascend, but I wanted to do a like-for-like. So I'm going to use this the demo data set for the S3 connector. So I'm going to do use. It's going to go ping that source. It's going to bring back what's available. Again, I'm going to pick weather. I'm going to pick sensor by day, and I'm going to pick the same source. Okay, but what I'm going to do actually is I'm just going to do some renaming of these components. I'm just going to call that raw weather data so we know exactly what it is. I'm going to use blob as the matching pattern. I'm actually going to bring across all my weather data rather than just one CSV file. I'm going to bring that all across. It's a CSV file and it's got a header row. So nice and straightforward. What I've done is that I've picked up my file and I'm going to automatically generate schema. Now, this is a real plus point in Ascend, that it pings the source and it generates the schema, and then you don't actually have to have the target table in place. So now I'm going to do create. And then all of a sudden, what Ascend is going to do, it's going to go into a mode where it automatically ingests that data, right? So now, without having to trigger anything, I've pulled that data from S3, and Ascend is intelligently partitioning that data so that it's going to be optimal as it moves through my pipeline. But it's doing that ingestion out of the box. There's no triggering, there's no scheduling. It's pulling that data straight away. Okay, so now what I'm going to do as a next step is I'm going to do my post-load transformation. So I'm going to go there, I'm going to create new transform. Okay, so here I can transform my data using Snowflake SQL, PySpark, Snowpark, or Park SQL. I'm just going to use Snowflake SQL for this one. This step I'm going to call define rainy day. So I'm going to add some post-load transformation. Just going to pick up, I've gone full Blue Peter style. If you're in the UK, you'll know what that means. But this is a SQL query I prepared earlier. Let's reformat that so it looks a little bit neater. And what you'll notice is that you just put that SQL in and then you do create. And then what it's going to do is the red defines a post-load transformation, the blue defines an ingest. And what Ascend has done in that time, it's ingested those 2 million records, partitioning it along the way, and now it's actually doing the transformation. So essentially what we've done in Ascend in that few steps is mimic what I did earlier in ADF as well. And it's pulled that data across. And the really neat thing is that you can view a little preview of the data directly from Ascend. There we go. That data's there. And also we've got the data for the post-load transformation as well. And you can see that data appears. Okay, so the next steps, let's go a little bit further while we're still waiting for ADF to finish. Let's now create a new transform here. And let's, rather than do that, let's actually add some PySpark. So what we're going to do is add a PySpark transformation here. Quickly, just going to use a partitioning strategy, which is reduce all partitions to 1. And you can see here, it's just going to take a vanilla PySpark function. I'm not going to add the PySpark essentially, but I'll just make it run through the process. Do create there. But I also want to add another flow here. So let's add a new transform as well here. But this one, let's do Snowflake SQL. Just add some more SQL in there. Max sensor by date. Perfect. Just steal some more SQL from my right-hand side. Perfect. Do a little reformat there. And that's it. Let's do create. So now what it's doing, and you can see it running, it's automatically ingesting that data, and it's giving me confidence that data is running, because if it errors, then it will go into an error state as well. Okay, so now the final piece is data delivery. So while we're here, what I'm also going to do is I'm going to deliver that data out to something called data share. So Paul alluded to it earlier, but I'm going to share my data out with other members of my organization, essentially into a data share. So I'm going to go create a data share called yearly prediction for that, create. And for this one, I'm going to do a data share. Again, another data share. Let's call that max precipitation by webinar today. Okay, that one. And also for this one, just to complete the whole journey, I'm actually going to write it out somewhere as well. And I'm going to write it out to SQL Server. If I can find it, there we go. I'm actually just going to browse and select data. So now I'm going to ping my SQL Server instance. Just go there. Perfect. So I'm going to select that. So now I'm going to click the upstream connector. I'm going to connect it to max sensor data. So you've got this concept of upstream where you want to grab the data from. The right strategy, I just want to do a full load. You've got options as well there, but essentially create. And now what I've done is I've created an end-to-end flow. You've got ingest, you've got transformation, 2 layers, and you've got data delivery as well. And this is essentially a write to reverse ETL. I'm just actually going to show you something else as well. We can actually pause the components. So directly from here, I can actually pause and restart my components such that you can actually develop. So you don't have to have the right target in place. You can just create it and wait for it to process. So in that time, what I've done is that I've created a full diagram. So let's head over to ADF again. And I'm just going to refresh that, and that should have finished by now, and that's finished. So you can see here, we've got the data that's landed in ADF, raw. So that's ingested. And now the sync has now, hopefully should have landed data as well. So essentially what we've shown here is that in Ascend, you can connect to any S3. It doesn't have to be like any blob storage. It doesn't have to be on a particular cloud instance. You can connect to any Snowflake, and that doesn't have to be on any cloud in particular. It doesn't have to be on Azure. It can be on AWS, etc. as well. So you've got this ability to connect anywhere, create your transformations, have the ability to share that data or write to a target within a super fast amount of time. But the most important one for me is the ability to understand that data's moving. So this movement of data and saying it's up to date is actually very important when it comes to debugging and developing as well. If there was an error, then you could actually that's not the right one. If I go to view information, I can actually go to errors and warnings, and it will actually show you the errors right there as well. So it will go into an orange state, the component, so you can clearly see where your errors are. And also Ascend offers you the ability to notify using webhooks and also email as well. So if you, like Paul said, if you're running this in the evening and something happened to the pipeline for one reason or another, then you'd get notified of that error. So you wouldn't have to actually go back the next morning and understand there was a failure. You'd be notified about that straight away. Okay, so exactly what Paul said earlier and in that little video, what I'm going to do is really highlight one of the main differences between ADF and Ascend. So what I'm going to do here is I'm actually going to ingest from another source as well. So I'm going to ingest from Postgres. So now pick a nice little database here, going to wait for that to load, go to public, pick a table. Okay, so schema name, everything's fine. I'm going to generate the schema. Again, Ascend does that for you automatically, so you don't have to do it. And then I'm going to do, actually, let me just rename that to weather stations, because what we're actually going to do here is we're going to embellish the data coming from source and blend that data with the raw weather data. So quickly here, what we've done is introduce the new source. And then what we're going to do is blend that data just using some really pretty straightforward SQL. So I'm going to now create a new transform. I'm just going to change that. And what you'll actually see here is that Ascend is using Ginger syntax so that you can auto-complete as well. And we'll see that in a second. So weather trace stations transform, going to do create. And then all of a sudden, you can see that data has been ingested from both sources, and now it's running through. But my DAG looks a little bit skew-if here. So what I'm going to do is reattach this to here. So I'm going to edit this component now, and I'm going to go there, and you'll actually see the Ginger kick in now. So you can see put in W, is going to connect, auto-complete for me, and then boom. And what you'll notice now is that Ascend understands the difference and automatically replays the rest of the pipeline. And that's an important part of the Ascend secret sauce, because you're having to do less work. And when Paul talked about automation, that is automatically understands where you've got in the process and subsequently is replaying all that data for you. So it's just less work for you. And also you can be confident that Ascend is picking up all the downstream components which are affected by your change as well. And you can clearly see it running through. And that's a big difference in Ascend, that you can understand where that change has got to. So no longer waiting for a batch run to be completed at 11 p.m. or 1 a.m. when it's a kind of a low transaction time. You can do it in real time, and you can do it right within the platform here. Okay, one of the last things I just wanted to show you an Ascend is the data shares. So if I'm on the finance team and Paul's on the marketing team, and I wanted to share some data here with Paul, then he wouldn't have to look at the finance data. I could just prepare a data share with him, and then he could subsequently just do connect to data share and pick up the share that he wanted. So he could just go down here and say, okay, I want to grab the accounts data from Elish's team. He could subscribe to it, and then all of a sudden create it. And now that data share has appeared in the new data flow, such that as an organization, you can now componentize, I'm not sure that's the right word, modularize, probably better one, modularize your data into sets where you can share between different departments. And then you can be confident that you've got the best data, and you're no longer do you have to reinvent the wheel. But that's not the best bit about data shares, because now I've created my pipeline and shared my data. As soon as my data is updated, then the share is updated as well. So the downstream consumer of my data share gets the most up-to-date data. And that's a real bonus in making sure that downstream subscribers of my data can always have the latest data and the latest business logic, which is associated with that data as well. So I'm going to hand it back to Paul. I hope that made sense, but if you've got any questions, then please do give me a shout.
Thank you, Alesh. That was very instructive, and we really appreciate the work that went into kind of putting all that stuff together so we could take a look at all of that. And yeah, and I think with the orchestration components of that too, Alesh, gets really powerful. You mentioned the data
Yeah.
shares and automatically propagating, but imagine if you've got 20 or 30 people subscribed to that data set, 20 or 30 different pipelines. No longer would you need to go manually track down which pipelines are dependent on these, maybe use like an observability layer on top of your pipelines to understand the relationships there, and then try to manually go through and, okay, how do I write the logic to rerun some of these pipelines and make sure that they rerun in the correct order?
Yeah.
The platform just figures that out automatically, which is lovely. And some of you might recognize that as a data product potentially. If you're doing a data mesh type of implementation where you want to just share a particular output of a data pipeline, but you not necessarily give access to the entire data pipeline. There might be security reasons or data privacy reasons why certain people in the organization should not have access to specific pipelines, but they should be able to consume the output of those pipelines, which once again is another benefit that you get of automation, which is a nice segue into our kind of closing, which is let's review some of the benefits of the automation. So what we saw today was we saw the building of an Azure pipeline in this case, an Azure Data Factory. And we saw the kind of manual components of that. And then we saw how easy it can be when you have all the automation that's baked in for you. Not to say that folks can't build their own kind of automation things if they wanted to, create their own application, so to speak. But there's a lot of work involved, right, Alesh? There's a lot of getting the metadata out of Azure Data Factory is non-trivial to understand what's happening across all your pipelines, and then organizing that metadata in such a way that you can act on it, and then building a controller that kind of has the techniques and the technologies to say, okay, I'm now got one hand in the orchestration layer of Azure Data Factory, and I've got another hand in the metadata, and I'm like puppeteering the two together is completely a non-trivial exercise, which is why we've built a platform like Ascend.io that allows you to do this all kind of out of the box. And one of the reasons why the best way to automate your Azure Data Factory pipelines or your Azure Data pipelines is to port them into an environment that is conducive to automation. And we also saw how much more time that can save you just across the board as well. And that is what we see when we look at some of the benefits of automation. We see game-changing efficiencies. And we hear this time and time again from folks who use the Ascend platform that, oh my gosh, this is amazing. I am 7xing the number of pipelines that I can manage as a data engineer because I'm not being pulled into a lot of these manual tasks anymore. I just know the pipelines are running, and when there's an error, it's very clear what's happening. I can go in and I can fix it right away. One of the things we did not show you today was that we can show you on a global level all the errors and take you right into the specific pipeline that's failed, and not just there, but right to the specific step that's failed. So when you do dive into an individual pipeline, you go right to the problem. You see what the problem is, you fix the problem, you're out, and then the system just goes back and continues its work of rerunning the pipelines to keep everything up to date, which is super powerful. So as an engineer, you can imagine I can just get more stuff done because now I don't have to be doing the drudgery of the job anymore, and I can just hand it over to the platform. We also see reduction in costs of tooling as well as we think about consolidating from multiple different point solutions into a single platform. And Ascend is actually quite cost effective for what it does. We do see folks that say that they can save at least 75% of what they pay in terms of rent on these different tools that they might have been using before. And we also see reduction of compute on workloads. And that's one thing that some people say, hey, this is all well and good, but I work on my pipelines all the time. And if you're going to rerun them all the time, then that sounds to me like it's going to cost a lot of money, a fair bit of change. But in the aggregate, the way that the Ascend platform works is twofold. We have the ability, as Les showed you, to pause pipelines so that if you're going to do a massive amount of changes, you could pause the pipeline and just do all your changes and re-enable it. But actually, the way that it works with the partitionings and everything else that's built in, the incrementality that's built in by default in the platform is it only makes a change. It only reprocesses a data set where it's absolutely required to do. So in most cases, when it's an incremental pipeline, it only reprocesses a subset of the data because that's the only thing that's impacted by the change. And then in other cases, we're able to replay the pipeline, but only from the point of change forward. So if you can imagine old paradigm where you don't really have a lot of sense of what's going on with your data, you got to rerun your pipelines a lot. And that's what we see in a lot of older paradigms, people coming from Airflow or other types of orchestration layers. And they're just used to this. And yeah, I got to rerun the pipeline. I'm sorry, but there's a couple million records, a couple billion records in that table. I just got to reprocess the whole table because there's no other way to do it than to just say, I can't guarantee that everything is compliant and up to date. But with Ascend, you get that guarantee because of the fingerprinting and the SHA hashing technologies that we use to give you a little bit more insight into how the platform is actually working. It's taking lots of SHA fingerprints of everything, of the data, the code, the data and the code together. So then you can say, okay, great, SHA broke. So what does that mean? That means that something changed. What changed? Oh, it's the data that changed. Okay, I got to reprocess all the data. Or it's the code that changed. Okay, great. So what parts of the data set are impacted by that? Which partitions of the data set are the SHAs broken for, and rerun those partitions. So that's how we do it. And that winds up saving you actually a lot of money on your compute as well. And just to sum it all up, what are some of the benefits of moving to automation? Certainly you get flexibility to be able to, as Alesh was showing you, really do things quickly. So that means that you can do more things in the same amount of time, which is great because you can experiment more. You can fail fast, to use a overly used Silicon Valley term, but you can basically experiment and play around and have fun with your data, processing your data and understanding what's there and what's possible from it and whatnot, which is why we all got into our various roles in the first place, right? Was to explore data and enjoy doing it. You can implement more complex use cases for sure. You can be more cloud agnostic, where you can ingest data, as we demonstrated, from a different source on an off-platform thing on, for instance, AWS, and then port it out as well if you needed to, and more enhanced debugging capabilities, and of course, automation for efficiency, so you don't have to rerun your pipelines all the time as well. So that's that, and I hope you found some useful information from this lab. And I guess, Alesh, maybe one question to put you on the spot here as we head out the door. So what was your primary takeaway from this experience of building in Azure and building in Ascend? Like, what, if you could bottom line it for us, what would you say is like the most impactful thing that you saw as a difference between the two platforms?
I think there's definitely the ability to be cloud agnostic, like the ability to take data from anywhere. So you're serving different use cases and you're not really having to worry about, oh, where is that data hosted? I think observability is very important as well, because as you're landing data and taking data from here to there, you want to make sure that data is landing as you'd expect. One of the things I didn't really point out was you can't see the data as it moves through the platform in ADF. You can see it, but it's a little bit of a journey to get it. And seeing that data as a developer, I believe is super important, just so that you can pick up any errors earlier rather than later as well. So I'd say cloud agnostic is important, observability is important with that debug approach as well, and also the ramp. So if I was a new data engineer, and Jenny, I know, experiences me building the pipeline with ADF, it's got some very nuanced behavior in terms of how to build. So if you've got a new data engineer and they're learning ADF for the first time, the learning curve is definitely steeper, and with Ascend, it's way more intuitive as well. So those are the real kind of things I took away.
That's awesome. Thank you, Alesh. Yeah, totally mirrors a lot of what we hear from folks who have had experience in both platforms and are transitioning towards a more automation-oriented perspective. We did have one question that came in from the audience really quick, so, and it's probably a pretty quick one. This person says, first of all, thank you for the session. It was super interesting. They said, what are the key challenges faced with integrating platforms like Azure or GCP or AWS? Key challenges.
Okay. I'd say the key challenges are having something that can allow you to integrate with all of them. I think as you work in the space, it's important to understand that you don't forever want to be like you'll get customers or sources where the data is hosted in different places. So I'd say, first of all, that ability to connect to anywhere is important. And also the concept of staging, exactly what you said. When you're staging that data at every level in that transformation, that data was materialized in my underlying warehouse. So that's something that you can do in Ascend as well. But Paul, did I answer that correctly, or?
I totally agree, Alesh. I would say in terms of macro level challenges with integrating platforms across these different microservices, or these different hyperscaler platforms rather, is the cost of moving data around can grow on you if you're not careful. The way these platforms are designed, they make it really cheap to get your data into the platform. They make it really expensive to take it out of the platform. And so if you can imagine, if you're in a world where you're moving data a lot between, let's say, GCP, AWS, or AWS and Azure, you're going to be paying a hefty price on one side of that transaction, right? AWS is going to charge you a lot to move it out, or makes it really cheap to move it in. But then if in the future, if you ever move it from Azure into GCP, Azure charges you a lot of money to move it out, whereas GCP makes it basically free to bring it in. So to minimize the movement of data between different platforms is important from a kind of cost operations or FinOps perspective. And so that's one thing that we encourage people as much as possible to transform the data in place. So if you're on Google, then use BigQuery, because BigQuery is a great transformation engine, and it can handle massive amounts. So if you've got a lot of website data, Google Analytics data, marketing data from various platforms, and Google Ads or things like that, and it's all in GCP, we have a lot of people that process it in GCP and then at least reduce it down to a smaller data set. And then they'll move that data set over to Azure if they're doing a lot of their analytics on Azure. Their enterprise-wide analytics are happening there. Or they'll move it into AWS if they've got an application that's built in AWS and they need it in an RDS table or something like that. So there's lots of different strategies, but that's the first one that you think about is, can I process the data where it is, first of all, and get it to a smaller subset of what actually matters for me? And then let's move that to a different platform and then work from it there and blend it in with some of my other data sets and things like that. So that's one thing. And also speaks to, Alesh, what you were saying in terms of the multi-cloud, multi-platform approach is if you have an integration platform that makes it possible for you to do all that stuff without leaving the platform, even better. Because then you're not jumping between Google specific pipeline tool to an AWS specific, AWS Glue, for example, specific pipeline tool, to Azure Data Factory for an Azure specific data pipeline, and trying to coordinate those three that are not integrated at all with each other is quite painful, versus if you're able to just say, hey, I've got a data pipeline platform and it just sees everything and it just processes everything. It doesn't really care if it's processing and pushing down into BigQuery or Snowflake on AWS or something else. Then it makes it that much easier to do.
Definitely.
Super. All right. We're going a little bit over, but I appreciate the questions and the insights from everybody and whatnot. So thanks everybody for hanging on with us. And like I said, if you have any other questions, please let us know. Please reach out. Don't be a stranger. Thanks again for attending the webinar on how to automate your Azure Data Factory, Azure Data Pipelines. And Alesh, thank you to you, sir, for all the work you did to put in and create this experience for us.
Thank you so much, everybody.